Good evening, students. Ninth class second chapter name is Polynomials and Factorization. In that first subtopic, that is 2.1 introduction. In that introduction we have to discuss 7 things, 7 points. I think okay na? What is first point? We have to discuss about variables or literals. Second thing, numerals or constants. Third point, operations of only variable, only numeral, and combination of variable and numeral. Fourth topic, expressions, we denoted with E letter. And expressions mainly we design two parts. One is a numerical expression. Shortly we can say that NE, N in a sense, N here the numerical expression here is. Okay, one more is algebraic expression. Shortcut we can call as AE. Next, fifth point is conversion of numerical expression to algebraic expression. Sixth one, polynomials and non-polynomials. Seventh one, the uses of polynomials. These 7 things we have to discuss under the title of 2.1, that is introduction. Okay na? Alright. About the first point, that is variables or literals. Variables, another name is literal another name is variable. However you treat, both are same only, but what are the variables? So before knowing the variables, let us see this polynomial and factorization is the main subtopic in the algebra chapter. Algebra is a very lengthy book. In that algebra, the beginning basic points are variables. I think I can feel that algebra can start with variable or literals. I think okay na? But come to the point. In English subject there are 26 alphabets there, no? Those 26 alphabets we can call as literals or variables in algebra chapter. In English subject alphabets, but same 26 letters in algebra chapter. In main mathematics in algebra we can call as variables or literals. Okay na? Right. Next, second topic is numerals. Numerals is another name is constants. Constants. What is this idea? Second topic is the numerals and constants. See, in algebra chapter, numerals another name is constants. Constants another name is numeral. Both are stands same meaning. But what is actually numerals? Simple. Come to the mathematics, a number system. In that number system, all numbers there, no? In number system, all values are called numbers. But same numbers in algebra chapters we can call as numerals. Numerals are constants. Based on the topics we can change the names. In number system same figures are called numbers. Those numbers in algebra we can call as numerals or constants. Okay na? Right? Next. Third point is operations. Case 1, only variables. Second, only numerals. Third one is combination of variables and numerals. What is that? See, operations. Nothing but operations mainly place minus into division. are called operations. Those operations are connect to only numerals. Variables. Now I am taking two variables. Those are mainly x comma y. Two variables are x and y. Now I am connecting place operation. X plus y, x minus y, x into y, x divided by y, where y is not equal to 0. What happened? I got few more details about okay, I got few more things based on operations which are connected only in variables concept. Now second round, what to do? Take numerals. For example, 2 is one numeral, 3 is another numeral. Now just connect the operations. 2 plus 3, 2 minus 3, 2 into 3, 2 divided by 3. I got 4 more. But come to the thought moment, combination of variables and numerals. In a sense, you take one which is belongs to variable and 5 belongs to n, nothing but numeral. X is a variable, 5 is a numeral. Their combinations, and connect with the operations. X plus 5, x minus 5, or 5 minus x, right? Next, x into 5, 5 into x, however. Next, x divided by 5, 5 divided by x, where x is not equal to 0. I got 1, 2, 3, 4, 5, 6, 7. So I got few more things. Here carefully observe. Title is operations. Plus minus into division. Those are connected to only variable. X comma y variable. Now x comma y are connected with operations. I got 4. And those 4 operations are connected with the numerals. See, observe carefully. I got 4 more. Now combination of variable side and numeral. Variable side x, numeral side 5. Now when those x and y are connected with operations, I got these all things. Students, be attention. Okay. Listen better. Fourth point, that is expressions. In these expressions, we have to discuss point 1. All variables a, b, c, d, dot till z. Second round, all numerals. Under the numeral things, we can see natural numbers, whole numbers, integers, fractions, decimals, rationals, irrationals, real numbers. Real number in a sense, when these all are making together, we can treat as a real numbers. See, natural side 1, 2, dot. Whole number side 0, 1, 2, dot. Integer side dot, minus 3, minus 2, minus 1, 0, 1, 2, 3. These are integers. Fraction side 1 by 2, 3 by 4, etc. Now decimal side 0.5, 0.3 bar, 0.4, 3, 4, 4, 3, 4, 4, 4, 3. These are decimals. Now rational number side, which can be written like 5 by 2, 5, 3, 0, 1 by 2, minus 1 by 2, minus 3 by minus 4, etc. These are rational numbers. Irrational number side 0.1, 2, 1, 1, 2, 1, 1, 1, 2, etc. And square root of 2, cube root of 3, etc. These are irrational numbers. When these all values are mixing together, making together, we can get a real numbers. Okay, this is no problem. Let us go with third point to that. What is third point? See, x comma y are belongs to variables. Previously we discussed this. Then by connecting the operations, we can get x plus y, x minus y, or else y minus x, right now, x into y, and y divided by x, or x divided by y. Here x is not equal to 0, here y not equal to 0. Conditions. Let us go with the fourth case, 2, 3, which are belongs to numerals. When these are connected with operations, we can get 2 plus 3, 2 minus 3, 3 minus 2, 3 into 2, 3 divided by 2, or 2 divided by 3, etc. Last thing, x is belongs to variable and phi is belongs to numeral. If you take like that, now while connecting operations, x plus phi, x minus phi, x into phi, x divided by phi. Here phi divided with x, where x is not equal to 0. Here phi minus x. Students, I wrote many things in this. Different things are there. These all are called expressions. Once again I am announcing. Here I wrote 5 things. No, Roman number 1, 2, 3, 4, 5. All different there. These all are called expressions. Okay, got it? No doubt, no. Right, wait. Next, I want to say one more important thing, that types of expressions. See, types of expressions I want to carefully observe. There are 2 types. One is numerical expressions. What is that? Numerical expressions. One more is algebraic expressions. In numerical expression side, variable involvement should not be. No variables in this. At least one variable required. At least in the sense you take more than also. At least one variable is required. Here no variables are required. Based on that, expressions are mainly 2 types. One is the numerical expressions, algebraic expressions. Numerical expressions are we should not consider variable, should not be the variable, but here at least one variable is required. So in this total, I want to list out the numerical expressions with a circle. I can divide the numerical expressions, algebraic expressions. Thing is, numerical expressions are going to round it. Rest of that, algebraic expressions only. Let us see numerical expressions I am showing. This is a numerical expression. It is also numerical expressions. Numerical expressions both. See, numerical expressions many places are there. These all are numerical expressions only. Why? Because all numerals are there, no? See, every number is not connected with a variable. No variable, moment no need. So these all are best examples of numerical expressions because of there is no variable of every number. And few more I want to show. This is also one of the numerical expressions. These 2 also numerical expressions. This is also numerical expression. These 2 also numerical expressions. So now see carefully this total and this 4. Those are best examples of numerical expressions. Okay, na? Next, rest of things, rest of in a sense remain. A, B, C, D, dot dot dot, Z, and these here variable involvement, there everywhere variable involvement. Those are called algebraic expressions. I think understood. So under the title of expressions, we divided two parts. Few are numerical expressions and few more are algebraic expressions. Numerical expressions are rounded with a circle, remaining are algebraic expressions. I think okay na? Okay, right, done. Okay students, fifth point, see, convert or else conversion or else conversion. Okay, convert numerical expressions into algebraic expressions. It is very important, try to understand. Right, example, see, suppose numerical expression, for example, can I take 5? 5 belongs to numerical expressions. NE indicates that numerical expression 5. These 5 we have to convert to algebraic expressions. Just now we discussed now. Algebraic expressions, in a sense, at least one variable is required. So now I am showing now. 5 is a numerical expression, is going to convert to algebraic expression. Carefully observe how we are going to convert. See. 5 I wrote 5 ones are clear. 5 into, instead of 1, can I take x to the power of 0? 100%, no doubt. No. X to the power of 0 is equal to 1 only, no? Actually, our intention is, our main is, we have to convert to algebraic expressions which are connected with the variable. So that reason, instead of 1, I want to take x power 0. Next, 5 into x power 0, 5x to the power of 0. Then what happened? 5 is equal to 5x to the power of 0. Mean 5 is a numerical expression. It is equal to 5x to the power of 0. It is algebraic expression. In a sense, you clearly understood that numerical expression is converted to algebraic expressions. I want to show one more problem. Okay, right? Let us take one more question. For example, square root of 2. It is best example for numerical expressions. Okay. Now, I want to convert to algebraic expressions. Let us see. Square root of 2. Now, square root of 2 into 1. No doubt, no. Okay, na? Now, square root of 2 into 1 can be written as y to the power of 0. Why? Because we know y 1 is equal to y to the power of 0. Y to the power of 0 is equal to over 1. Now, I am multiplying this both. Square root of 2 into y to the power of 0. That means square root of 2 y power 0. What happened? Square root of 2 is equal to square root of 2 y to the power of 0. Observe carefully. Okay, na? It is a numerical expression. Is converted to algebraic expressions. I think okay. So through this you conclude that every numerical expression is going to convert algebraic expressions. Once again. These two examples are enough. Previous one, this one. Through that we conclude that every numerical expression is going to convert algebraic expression in such a way. So very important thing I am announcing. Be attention. So carefully listen. Every numerical expression is one of the algebraic expression only. Mean, can I call square root of 2 is algebraic expressions? Yes. Why? Because we can convert, no? What is statement? Every numerical expression is one of the algebraic expression only. Through this statement we conclude that 5 is also one of the algebraic expression only. I think understood. Phi is one of the algebraic expression only. But thing is, based on this statement, we can convert. Phi is not connected with variable, but we can convert. So that reason, phi is one of the algebraic expression only. Just now I shown how to convert phi into algebraic. Phi into 1, phi into x to the power of 0, phi x to the power of 0. That means phi is equal to phi x to the power of 0. What happened? Numerical expression, that is phi, is converted to algebraic expressions. In a sense, phi is one of the algebraic expressions only. Please try to understand. Every numerical expression is one of the algebraic expressions only. 2-3 things observe. Every number, every numeral is one of the algebraic expression only. Because of every numerical expression we can convert to algebraic expression. So that reason we want to clearly conclude that every numerical expression is one of the algebraic expression only. There is no doubt. Okay, na? Okay, right. Okay, students, let us go with the sixth point. What is that? Polynomials, non-polynomials. What is actually polynomial? Polynomials. I think it is your chapter title, polynomials. So that's why carefully observe what is polynomial. Polynomial definition can start that the algebraic expressions, the algebraic expressions which is having exponents of the variables. See, the algebraic expressions which are having the exponents of the variables are non-negative integers are known as polynomials. Once again, the algebraic expressions which are having the exponents of the variables are non-negative integers are known as polynomial. For example, through example you can understand. Now I want to give algebraic expressions. Now I want to give a few algebraic expressions. For example, x square plus 4. I think understood. I took two algebraic expressions which are having exponents of the variable. Here who is variable? X. Its exponent 2. Here variable is x. Its exponent 2. Nothing but exponents of the variables are non-negative integers. Is it non-negative integer? Non-negative integers, another name is whole number. Tell me, is it whole number? Yes, no. Is it whole number? Yes. Mean, carefully observe. You take algebraic expressions. Yes, I took two algebraic expressions. And their exponents of the variable x there. Their exponents must be non-negative integers. In a sense, exponents of the variables must be whole numbers. Here its variable is x, its exponent is whole number. Here variable is x, its exponent is whole number. I want to write few more. 4x to the power of 3. Here y. Let us take y exponent 1, x exponent 3. Nothing but whatever the variables, their exponents should be non-negative integers, in a sense whole numbers. See, y power 1 is a whole number, x power 3 is a whole number, x power 2 is a whole number, here x power 2 is a whole number. Whatever the exponents of the variable, they must be whole numbers in algebraic expressions. Then only those are called as polynomials. Otherwise, they are not polynomial. I think understood? I wrote 3 polynomials. I am ready to write many polynomials. Right. Next, I think understood, very clear definition. You choose algebraic expressions, their exponents of the variables power should be whole numbers. That's it. Next. What is next? Now I want to discuss about non-polynomial. What is non-polynomial? Non-polynomials, in a sense, opposite to the polynomial. One example, x to the power of 1 by 2 there. It is an algebraic expression only, no doubt. Variable is x, no problem. It is algebraic expression, variable is x. These two sides, no problem. But exponent should be whole number, no. That here not. Your exponent is not a whole number. It is non-negative integer. It is not a non-negative integer. Nothing but it is not a whole number. Based on that reason, simple. Why it is non-polynomial? Because of its power. Its exponent is not a whole number. Not a non-negative integer. So that reason it is the best example for non-polynomials. I want to give one more. 1 by x. It is also non-polynomial. Reason, this can be written as x to the power of minus 1. Observe carefully. It is one of the algebraic expression only. Variable x, no problem. But exponent is problem. What is exponent? We need whole numbers, but here whole number not there. It is integer. So that reason, this is not a polynomial. This is called non-polynomial. Non-polynomial, in a sense, exponents of the variable must be not a whole numbers. Minus 1 is not whole number, no. That's why it is non-polynomial. I have many with me. X square plus x to the power of minus 1 plus 4 there. Is it polynomial? No. It is best example for non-polynomial only. Reason. Here exponents of this x, see, this minus 1 there. Minus 1 is not a whole number. So that reason it is non-polynomial. Simple. If you want a polynomial, exponents of the variable must be whole. Then that is a polynomial. Otherwise, non-polynomial. I want to give one more example. Square root of x there. Is it polynomial? No. Why? Because this can be written as x to the power of 1 by 2. What is exponent? It is not a whole number. So that reason, these are non-polynomials. So square root of x is not polynomial. X to the power of minus 1 is not polynomial. This is not polynomial. This is also not polynomial. Only reason is power should be whole numbers. But you are not there to make a polynomial. That's why these are non-polynomial. Why these are non-polynomial? Simple reason. Powers are not whole numbers. It is not a whole number. This is not a whole number. This is not a whole number. This is not a whole number. So that reason, these are best examples of non-polynomials. I think you got clear idea about what is a polynomial, what is a non-polynomial. Simple thing. To make a polynomial, two things. We need algebraic expression. Second thing, observe the variables. Third thing, their exponents should be whole numbers. exponents should be whole numbers. But non-polynomial side, condition 1, it should be algebraic expression. Second thing, variable compulsory. Third case, exponents should not be whole numbers. This is the major difference of polynomial and non-polynomial. Polynomial side, these three cases are required. One is it should be algebraic expression. It contains a variable. The variable exponent should be whole number. Then that is polynomial. Non-polynomial side conditions are it should be algebraic expressions, which is contains a variable. The exponents of the variable should not be whole number. Okay, na? Right. Okay, students. Last point, that is 7th. Till we discussed about the polynomials. Now this is the time to learn what about their uses. Right. I want to give one small use. See, this is generally we can feel that square. It is square figure. If its side is yes, now try to find its perimeter. Perimeter is equal to side place, nothing but length of the border, sum of 4 sides. However, this is equal to 4s. That is called a P. In P is equal to 4s. Now I want to discuss what is 4s. 4s is one of the polynomial. One more. Second. This is first, this is second. Let us think about this. What is this rectangle? It is the length, this is the breadth. This is the length, this is breadth. However, opposite sides are equal. So that reason, to find its perimeter, L place, B place, L place, B, sum of all sides concept. 2L place, 2B, right? 2 let us take common, L place B. That is what? Perimeter. Perimeter of the rectangle is 2 of L place B. Right? This is what one of the formula. In this formula, 2 of L place B, once observe, 2 of L place B. What is this? The polynomial. Through these two examples, you conclude that polynomials uses are mainly we can make formulas. But excellent, nice point. Tell me, what are the uses of the polynomials? With the help of polynomials, we can make formulas. You know the importance of the formula in mathematics. To make the formulas, we can use polynomials. Okay? Right. See, students, if I have any doubt, enter these 7 points. Just you post your doubts in my comment box, and you share my video and like my video, and subscribe my channel. If you subscribe my channel, you will get notification from me. Okay, na? Support me. Thank you.